Hello guys. So in this live session we are going to solve most of the problems that we are asking for, the number problems, and these are the problems that have been asked by most of the companies. So nearly we'll be solving around 30 problems. So this is going to be intense and we'll be seeing how to solve them from the scratch, that even if you don't know, so just carry on along with, so you'll be used to know. So in this session, so make sure to grab your IDE so you could code and you'll be getting the output. So let us move on to this. So first let me explain from the scratch that first every program in C having that header file hash include standard input output .h. So this is the header file. So in this, using this header file, then only we can use getting the input from the user and printing the output, that is scanning and printing. So the main, after that the main function. So this main function is nothing but the starting of the every program. So after that this return 0. This is the ending of the program. When the compiler reaches this line, the program will be ended. So now in the previous slide we have seen about if else conditions. In this session we are going to see most of the problems alongside with it. So first we will see even or odd. So in this problem, so we have seen it previously, so let us move on to that. So first I declare a variable. So after that I get input from the user using the scanf. After that I have to check that if my number is divided by 2, I can say it is a even number. For example, let us see some numbers. So in this number series, 1, 2, 3, 4, 5 and 6, 7. So here there are 7 numbers are there, and this 2 and 4 and 6 are even numbers. So let me break it down by even and odd numbers. So in these numbers, if I divide this number, for example let us take 7. So if I divide 7 by 2, that 3 times of 2 is 6. So I'll get the remainder as 1. Okay. So now let us take another number, example 8. So if I divide 8 by 2, 4 times of 2 is 8. So 8 minus 8 is 0. So I'll get remainder as 0 here, but here I am getting the remainder as 1. 7 minus 6, 1. So as you can see here, if you divide any number by 2 and you get remainder as 0, that is a even number. If you get remainder as 1, it is a odd number. So that's the same concept we are going to check using this. If my number divided by 2 will give the remainder as 0, it is a even number. If it is not even number, I can say it is a odd number. So let us run it and check for the numbers. So let us give 2 here. So it is a even number. So let us give 7 here. So it is a odd number. So as you can see, if a number is divided by 2 and give returns the remainder as 0, it is a even number, and if it gives remainder as 1, it is a odd number. So this is the basic concept. So in this we are going to use ternary operator, so it will be in a single line. So the ternary operator is nothing but first the condition. The condition is n modulus 2 return 0. After that, a question mark. And if it is true, then it has to print even number. If it is not, that time we have to give here a colon. After that, printf odd. So this is the same code we have written for the if else in a single line. Condition, and after that true expression and the false expression. If it is true, it will print. If it is false, it will print. So let us check it. So 2, it is even. For 7, it is odd. So we are checking in a single line using the ternary operator. So first we are including for input output functions here. After that we are getting scanf and getting the input from the user, and this percentage d is the data type that will specify the data type of it. After that, this is the address of the variable. Then I am checking if n modulus 2 remainder gives us 0 or not. If it is gives 0, then even number. If not, it is a odd number. So let us move on to the next question. So the next question is sum of digits. So let us see sum of digits. That is, for example, if there is a number 1, 2, 3, 4. So in this problem, we are going to add these digits like 1 plus 2 plus 3 plus 4. So if you add all of this, we will get 10. So in this program, we are going to add these digits and returning the 10 as the output. So let us see the basic concept for that. First, we have to get this last digit. We are going to iterate from reverse and getting the last digit. So getting the last digit is nothing but if you use, for example, if there is a number like 1, 2, 3. If I use modulus 10, I will get the last digit. Why? Because it will give the remainder. So for example, 123 divided by 10. So 12 times of 10 is 120. So 123 minus 120 gives the value of remainder 3. So as we can see here, if you divide any number with 10, and the remainder will be the last digit. So this number divided by 10 and the remainder is the last digit, that is 4, because it will be 1234, and if it is divided by 3, it is 123 times of 10, that is 1234 minus 1230. So this time the remainder is 4. So you can ask that what if the last digit is 0? So here I'll take one more example, that is 120. Okay, so if I divide by 10, so 12 times of 10 is 120. So 120 minus 120 give the remainder 0. That is also the last digit. Okay, the last digit is nothing but the 0. So this time also it will return the last digit. So if you divide any number with 10, that time you will get the value. So now you can see one more thing here, that is, if you want to remove this last digit, so that time you have to divide by 10. Same thing, 1, 2, 3, 4 divided by 10. Okay, 1, 2, 3. 1, 2, 3 times of 10 is 1, 2, 3, 0. This is what we are getting. Okay, see here, in this number we got, this is the output if you divide 10. This is the quotient and this is the remainder. Okay, the quotient is, if you divide this by 10, you will get 1, 2, 3, the 4 is removed. So this is the concept we are going to use here. So first we will see while loop. So what is a while loop? So while loop is nothing but a loop. Loop is the number of iterations that a code have to be done. For example, if I give printer hello world, after that I will give I equals 10, and if I give I minus minus, here I have to give integer. So it will print 10 times. So let us check here. So it is printing 10 times. So I have to use, before that I'll use percentage %d. After that I and next line. So now let us run it. So it is getting back in the reverse order, like 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. There are 10 times it is running. Okay, 0 to 9 there are 10 times, and this code is running 10 times. If I give 5 here, the code will be executed 5 times. So if you want to run a code but you don't want to write the same line again and again, so that time we will be using loops. There are two types of loops. One is for loop, another one is while loop. So when we are using these both two loops are, if you know the number of times the loop will run, that time you will be using for loop like this. This will run 10 times. But for the while loop, if you don't know how many times the loop will run, that time will be used. So you may ask, when will I know that how many times it will be run, or when to use for while loop and for loop? So for this problem, as you can see here, you don't know how many digits the user may give. For example, we can like give like this, or like 2 digit or 4 digit. This time you don't know how many times the loop will run. So that time we will be using while loop. So in this time we are using while loop here. So while first we see the condition here, that first what I am doing, first I am getting the remainder of the last digit, this number 1, 2, 3, 4, I am getting the last digit. First I am getting the last digit and I use any variable to store it. First it will be 0. So sum plus sum equals sum plus equals the current last digit 4. So this 4 will be added to the total sum. So after that I have get the remainder. So now I have to remove this. So if I divide the number by 10, so that time it will become 1, 2, 3. So now here 12 times of 10 is 120. So 120 minus 123 is nothing but the remainder is 3. So the current value plus 3 is 7. So the current value of sum is 7. So after that we will remove this last digit. So we will get 12 here. So 1 times of 10 is 10. So 12 minus 10 will return the give the output as 2 as the remainder. So 7 plus 2 is 9. So the sum will be 9. So the last digit will be removed. So the current number is 1. So 1 divided by 10. So see here, if a number is less than 9, okay, if a number is less than 9, for example 1, 2, 3, 4, 5, 6, 7, 8, 9. For these numbers, if you divide by 10, okay, that time the quotient will be always 0. After that the remainder will be always the same number. because in integer division you will get 0. If it not for the integer division, it will be like float values. So that time you will get 0 point some values. Let me take 5 here, that time you will get 0.2. So same like that, this will goes on. So that time the value of the quotient is 0 for integer division and the remainder is the same number. So if you divide the same number, that time the n will become 0. Finally the n will become 0. So after that you have to add the remainder, that is nothing but the same number. The same number is 1. So 9 plus 1 is 10. The sum is finally 10. After that the current value of n is 0. So the condition is, if my n becomes 0, I can stop it. So that is, we are going to give the condition. While my n is not equal 0, okay, when my number is not equal 0, I can do this. So for that I will declare n and I am getting it from the user. So before that I am using printing statement. So enter the number. So after that I am getting the input from the user. So I am giving the condition while n is not equal 0. After that, so I'll have to add it to some, I am storing a variable to add it. So for that I'll declare one more variable, so named as sum. So the first value is 0, initially it is 0, so after that it will be incremented. The current value of sum is 0, so while n not equal 0, so first what we have to do, we have to get the remainder. So for that I'll declare one more variable named as remainder. So n modulus 10 will give the last digit. After that I am adding it to the sum variable. I am getting the last digit. See here, for example, let me take 1, 2, 3, 4. I am getting 4. This value will store 4. So I am adding this 0 plus 4. So after that we have to delete the last digit. So for removing the last digit, I just have to divide by 10. N equals n divided by 10. So this time the last digit will be removed. After that it will move on to here. Again it will do the same code. For example, let me take this n as 1, 2, 3, 4. So now what will happen? It will check 1, 2, 3, 4 not equals 0. So it is true, it will get into the loop. So the remainder will store the last digit, that is 4. Sum equals sum plus 4, that is 0 plus 4. So the current value is 4. So the n will become 1, 2, 3 because it is divided by 10. So last digit will be removed, it will become 1, 2, 3. So it will check again 1, 2, 3 is not equal to 0. So it is true. So it will get here and store the last digit, that is 3. Then after that 4 plus 3 will become 7. So it will remove the last digit, it will come here 12 not equal 0. So after that it is true, the last digit will be get into the remainder value. So after that 7 plus 2 is 9. 7 plus 2 is 9. So after that this 2 will be removed. So now 1 not equal 0 is true. So after that the last digit is nothing but 1. So 9 plus 1 will become 10. So after that if you divide a single digit with 10, it will become 0. So 0 not equal 0 is false, it will get out of the loop. So we have stored 10 in this variable. So now we have to print it. Printf the sum of digits of this given number is the sum. So n comma sum. So let us run it and check. So we will give the number as same number. So it is says the sum of digits of 0 is 10. Okay, why? Because finally the n value will become 0 here. So that's why it is printing 0 is 10. So here we can do one more thing, that is I am using a temporary variable to store the n. So here in the printing statement I can remove this n and make it as temporary. So if I run it and give the same number 1, 2, 3, 4. So now it says the sum of digits of this digit 1, 2, 3, 4 is 10. So this is how we will be calculating the sum of digits using the while loop. We can do it in a for loop. So let us see how it is doing. So for that I will remove this. The same condition but in for loop. For we know that syntax, that is the initialization and condition, after the condition the updation part. But in for loop all of them are optional. We can just simply give this two, so it will work. For example, if I give any values, so let us run it. So if I give any number, so it is goes on, this hello is being printed unlimited times, that is infinite times. So that's why this within this for loop all of them are conditional, but we have to give this semicolon here. So that is the syntax. So I am just removing this. So for we don't need to initialize anything. So after that, so for that I'll give the semicolon. So now I'm using temporary here, or else we can still use the n here, the same condition, n not equal 0. This is the condition. So the updation part we have done inside it, that is we are removing the last digit. But here we have to give here itself, n equals n divided by 10. So after that, the same thing, sum equals sum plus n modulus 10. I have previously stored in a variable, but I am currently adding in a same variable. So after that, that's it, we just have to print it. So let us check. The number is 1, 2, 3, 4. So the sum of digits of 1, 2, 3, 4 is 10. We have used the same method, but in the for loop we have given in this condition here, after that the updation part here. And if you are any confused during this, I'll just name it as reminder. After that, in reminder equals n modulus 10. The same code, but we are doing in the for loop. So for that, after that, we will move on to the next question. That is reversing a number. Okay. So let us take the same example here. That is 1, 2, 3, 4. If we reverse it, we will get 4, 3, 2, 1. So let us see here. That is ones, tens, hundreds, and thousands. These are the digits. Ones, tens, hundreds, and thousand. Same here, ones, tens, hundred, and thousand. So for these numbers, as you can see, it is the tens is increasing one by ones. So that time, the same thing we are going to do it. We are removing the last digit and adding at the front. Okay, first, this current value of sum will be 0. So after that, sum equals, sum will be multiplied by 10. 0 will be multiplied by 10. After that, this digit will be added. Okay, now if you see here, the sum value is 0. So 0 times of 10 will be also 0. So 0 plus 4 is 4. Now we got the first digit, that is 4. After that, we will see here the next digit is 3 here. After adding it, we will remove this number. Now there is 3 here. So the current value of sum is 4. So after that, we will get the remainder as 3. So the current value of sum will become 4. 4 times of 10 will become 40. So 40 plus 3, the remainder is 43. So that time we have reversed the last digit. We have reversed this last 2 digit. Same goes for that. That is, the next digit is 2. So the current value is 43. So 43 multiplied by 10, that is 430 plus 2. This is 432. After that, it is 432 multiplied by 10, that is 4320. After that, we will add 1 here. So it is 4321. So now we got the desired output. So what we are doing, we are multiplying every time the current value by 10. After that, adding the 1 digit. So that time we will be reversing this number. So let us see on the code. The same method we will be using for loop here. So I am storing this temporary number. So after that, the same sum equals 0. Or else I will name it as reverse. So the same condition, because we have to iterate through the last two first digit. N not equal 0. So now what we are doing, reverse. See here, the reverse multiplied by 10, and after that we are adding the remainder value. So reverse equals reverse multiplied by 10, and we are adding the last digit, that is n modulus 10. So after every time you are adding, you have to remove the last digit. That is the updation part. So n equals n divided by 10. So we are dividing 1 by 1 digit, so that time the last digit will be removed. So we will move on to this. The reversed number of this number is this. So the temporary number is reversed. So let us check it. We are doing adding tens by here because this ones, tens, 100,000. So it is multiplied by 10 every time. So that's why we are doing this multiplied by 10 here. So let us check. 1, 2, 3, 4. So the reverse number of 1, 2, 3, 4 is 4, 3, 2, 1. So let us give some more numbers. 4, 3, 2, 1. So let us try to give some single digits. 9. So it is still 9. Because single number will be all, even if you reverse it, it will be the same. So let us take some negative values. Negative 98. Sorry, 89. So negative 89 is negative 98. So let us check. Negative 123. Negative 321. So why we are using n modulus 0 is because of this negative checking. Some of them will do that if n is greater than 0. So if, let us check here, that time if I give 1, 2, 3, 4, it will still work. So let us try to give the negative values. Negative 987. So that time it will not be work, because in this condition it will only work for the positive number. So that's why you have to always use not equal 0. So then even if you give negative values, that time it will work perfectly. It will not throw 0 instead of the reversed negative number. So let us move on to the next problem, checking a palindrome. So first, what is a palindrome? So a palindrome is a number that will be if you read the number from forward and backward, it will be the same. For example, if it is 1, even if you read it in the forward, it is 1. If you read it in backward, it is 1. So if I use 121, this number is still same, 121, and if you reverse it, you will get 121. So if you see here 3, it is not a palindrome because in the forward that is 1231. If in the backward 1321. So it is not the same number. So if a number is equal to its reverse number, so that time it is a palindrome. So we are going to write code for that. So as we have seen, this is the reverse number already. So this is the normal number we have stored in the temporary variable. So here the temporary variable number stored in there equals reverse number. That time I can print it is a palindrome. If it is not, it is not a palindrome. So let us check here. If I give 1, 2, 3, 4, it is not a palindrome. If I give 1, 121, it is a palindrome. If you reverse the number, it will be still the same. So let us see some more problems, some more samples. That is 0, 0, 9. In this, the leading numbers will be removed. Okay. So let us check it. So it is a palindrome. Why? Because these leading zeros will be removed. So after that, this 989 will be executed. So but if you try to give 0, 0, 989, 0, 0. So if you look at this, it will look like a palindrome, but if the compiler sees it, it is not a palindrome because it will remove this leading zeros. So the current number will be 98900. So if you use leading zeros, that time it will not see as a palindrome. So let us move on to the one more problem, that is counting the digits in a number. So as we can see here, in this previous problems, we are removing 1 digits per every loop. So as you can see, if you count the number of loops, okay, for example, the first loop, this will be removed, second loop, this digit removed, third loop, it will be removed, fourth loop, this digit will be removed, the fifth loop, it will be removed. So there are 5 loops. The 5 loops, if you count the loops, then you can print how many digits are there. So let us check here. So I am just removing this code. So after that, I'll declare one variable to count how many number of loops are there. So the same condition, if n is not equal to 0. So after that, I'll count by 1. After that, n equals n divided by 10. So now we have to print it because every time it will increase the count by 1. After that, it will divide it. So print the number of digits is count. So let us run it and check. It says it is 4. But if you count it after the division of this number, for example, if I cut it and paste here, this time it will be reduced by 1. For example, if I give any numbers, let me give 1, 2, 3. So it says 3. So but here it is still working perfectly. Why? Because it is not counting the digits. Instead of that, you will be divided, but even though it will be only counting the loop. So if you use this previously one more again, that time it will be reduced by 1. So we are counting this. So now we will be using the for loop. For, so this time I want to count. I am initializing a variable that is count. So after that, while that is the condition n not equals 0. After that, n modulus. So here we can't give here. So instead of that, we have to declare it here. So count equals 0. So here also count equals 0. After that, n equals n divided by 10. So here you will just increase the count by 1. You don't need to initialize it also. You just can remove it. So just run it. So I'll give 1, 2, 3, 4. So it counts the 4 digits. So most of the time, if you don't know how many times the loop will run, you will use this. Even now also we don't know how many times this loop will run, because you don't know how many digits of number the user will give. So that time we will be using this. But let us see here, if I give 0 here, it says the number of digits is 0. So that is a special case. For that, first we have to handle it. For that, if my number is 0, I just need to print it. The count is 1. Or else I can simply change the value of it, but I'll just print it. The value is 1. After that, I'll use the return statement. So it will stop the loop if the number is 0. So let us try to give negative numbers. So negative 987. So it is working. So let us give negative 1, 2, 3, 4, 5. So for the negative numbers, there is not a problem. But if you give a single digit of 0, that time it will also give 0. So make sure to verify in the all verticals that this code working correctly for every test cases. So let us move on to the next problem, that is Armstrong number. So what is an Armstrong number? A Armstrong number is nothing but that same number is equals to sum of its digits, and it is the power of the number of digits. For example, if I give 153, so there are 3 digits. Okay, there are 3 digits here. In this, 1 power 3 plus 5 power 3 plus 3 power 3. So that is 1 plus 125 plus 27. If you add this, that time you will get 153. 125 plus 27, that is 152. After that, if you add 1, you will get 153. If the sum of digits of its same number, power of this count is equal to the same number, that time it is an Armstrong number. Okay, the count is 3. You have to calculate the power. After that, you have to add it. If you add this, so that time, if it returns the same number, it is Armstrong number. So before that, we will see one more thing. If let us try to print that int count equals log 10 of the current number plus 1. For using this log, we have to import the math. So add include math.h. So I am using log 10 of n plus 1. If I do this, let us see, it returns 2 here, but it should return 3. So let us give another number as example, that 1. So it gives 0. It is log of n plus 1. So now let us run it. 1, 2, 3. So it is working. If you use log 10 of the current number, it will be giving the digits of number by minus 1. So we have to add it by 1. So let us try to give 0 here. So for 0, it will be giving some random value. So in that case, you have to give here n is 0. That time you have to change the count to 0. 5, 1. So if you run it, so let us give another some more number digits. It is 5. So if I give 0, so it is 1 now. So let us give some minus value. Minus 987. So for only positive values, you can use log 10 of n plus 1. So that time you can count it. So let us remove this. So this is one method. You can count it without using any for loop or while loops. So we are going to check Armstrong number. So in this, we are getting the input from the user. Return 0. See here, we are getting the input from the user. Now we have to first calculate the digits. So first we will calculate the digit, because the count will not be in, the count has to be checked. After that we have to add it with the power values. So for that I am using count equals log 10 of n plus 1. So count the digits of the number, or else you can do one more thing, that is to string, or else you can count it using for loop. So but I am currently using log 10. So log 10 of n plus 1. If my count is, my number is 0, that time my count is also 0. So I'm checking for the positive numbers. So let us move on to the next question. So let us move on to the next part of this question. That is, we have counted the power. So now we have to add it by powering up using every single digit. So the final value, I am using a variable to store it. So the sum value is 0. So after that we have to use a while loop while n is not equal to 0. So within this while loop, first we have to remove the last digit. So I am using a variable to extract the last digit. I am using remainder here to extract the last digit. After extracting, we have to run a for loop. So first let us see how to code for the power of a number. So first let me comment this. So first let us see how to find the power of a number. For example, 1 power 3 is 3 times of 1. 1 multiplied by 1 again multiplied by 1. So 5 power 3 is 5 times of 5 times of 5. Okay. So we can run a for loop this power times and multiply the number with same number. So let us write a program for that. So for int, so I equals 0, I less than 3 and I plus plus. So now I'll get the input from the user. After that I have to calculate it by multiplying it. So for multiplication I am using a variable that is result equals, I have initialized it 1. Why? Because if you initialize this variable with 0, so if you multiply it, you will always get 0. If you multiply any number with 1, you will get the same number. That's why for the multiplication purpose we are using 1 here. So after that, result equal result multiplied by the number by the same number. So first let us take example of n value as 5. So it will come 0 less than or less than 3, it is true. So 1 times of 5 will be 5. So again it will come. So the second time 1 less than 2 is true. So after that 5 is multiplied by 5. So after that it will become 25. After that here it will come 2 less than 3, it is true. So 25 is multiplied by it. So again it will become 125. So now it will come 3 less than 3 is false. It will get out of the loop and we will print it. Printer the cube of percentage d is percentage d. Because I am running this loop 3 times, that is nothing but the cube of a number. So after that n and result. So let us check. For 1 it will be 1. So run again. For 3 it is 27. So it is 27. For 5 it is 125. So we got the same values here by calculating the power. So this, instead of this 3 we will be using counting, because count times is nothing but the loop. So let us remove this. So let us see this uncomment and coded. So we are getting the input from the user, and after that we are extracting the last digit. After extracting, we have to store it. So I am using one more variable, that is result. So I am using 1 for the multiplication. So after that I am using a for loop. For int I equals 0, I less than the count. After that I plus plus. So here I have to multiply it, result equal result multiplied by the last digit, that is remainder. So this value will be get the power of this number, that is result. So you have to add it with the total sum. Sum equal sum plus the multiplied power value, that is result. After this loop it will be get multiplied. So here we have to check that if the current sum is equals the n we are given, that time we have to print it is a Armstrong number. If not, it is not a Armstrong number. So let us run it, but there is a one more bug here. That is, if I give 153 here, so that we didn't remove this last digit, so that's why it's running in an infinite loop. So let us stop it, because every time you will get the remainder, you have to remove it. So n equals n divided by 10. So let us run it and check 153. So it says it is not a Armstrong number, because if I try to print the n, let us try to first print the n. After that the d, percentage d space another percentage d and n and the total sum value. So let us first check it. So 153. See here, the first is 0 and another one is 153. So when this loop runs through every iteration, the n value will become 0 here. So for that we have to store it in some more variable. So using temp as a variable, I am storing it. So here we have to check it, temp. After that we'll print here as temporary. So now let us check for 153. So 153, 153, it says still not the Armstrong number. So if temporary number equals here sum. Okay, so let us run it and check 153. So it is an Armstrong number. So let us check for another numbers. So let us run it and check for first. Let us check 153. It is Armstrong number. After that, some more examples. For example, let us give 1 here. So 1 power 1 should be an Armstrong number. Let us check for another number, that is 9474. 9474. So it is also a Armstrong number. So that's it for this program. We have solved using this. First we have to count. Within that we are using one while loop for extracting the digits. Within that we are using for loop for calculating the power of the number. So after that we are adding it. So after that we are checking if both numbers are equals. If it is still equals, we will print it. So let us move on to the next question, that is prime number. So let us see for it. A prime number is nothing but if a number is divided by the same number and 1. Let us take 2. So the divisors of 2 is 1 and 2. So there are only 2 divisors, that means it is a prime number. So let us take 3 here. So 1 and 3 are the divisors. It can be, a divisor is nothing but, if I take 5 here, if I divide 5 by 1, 5 times of 1 is 5, so I will get remainder 0. If I divide any number with another number and I will get remainder 0, so that time it is called as a divisor of that number. So 1 is a divisor of 5 and 1 is divisor of all numbers, and the same number is also divisor of the same number. So that means if the number have only 2 divisors, that is a prime number. If I take 10 here, I can divide it with 1 and 2 5s are 10. After that 5 times of 2 is 10 and 10 times of 1 is 10. So see here there are 4 divisors, so that time it is not a prime number. Let us take 13 here. For this it is divided by 1, not by 2, not by 3, not by 4 and not divided by 5. 6, 7, 8 can't be divided and it will goes on and it can be only divided by 39. So it is also a prime number. So we can check from the number, that is we can use a range of numbers. For example, if I take 13, I'll get the range of 13. In this range from 1 to the same number, I'll try to divide with this number with these numbers. So then that time I have to count the divisors. So 13 by 1, you will get remainder 0. So I'll increase the count by 1. So 2, if you do that, you will get the remainder as 1. So you have to get the remainder 0, then only it can be a divisor. So if you use 2 here, that time also you will get remainder as 1. If you use 4 here, that time also you will get remainder as 1. Then if you use 5, you will get remainder as 3. Then if you use 6, you will get remainder as 1. For 7, you will get remainder as 5. Like that it will goes. So even 11 can't be do, because if you use 10, remainder is 3. For 11 it is 2. For 12 it is 1. And 13 it is 0. So that time the count will be incremented by 1. The count is 2. If my divisor count is equals 2, I can say it is a prime number. So let us come here and remove this code. So let us remove this. So we have to check from the range of 1 to that same number. So for that, first we have to declare a variable to count it. I am using a counter count. It is initially 0. So a for loop, I know the range of it, that is 1 to the same number. So for int I equals 1, after that I less than or equals the same number and I increase by 1. So in this loop, I start from 1 and end at the same number and increasing it. If my current number is divided by any number in the range and return 0 as the remainder, so I can count it. Count plus plus. So I will count the divisor count. After that, if my count is 2, that time I can print it is a prime number. Percentage D is a prime number, or else it is not a prime number. Okay, I am counting from the range of 1 to the same number, that is n. After that, I will count the divisors. If my divisor count is exactly 2, so that time it is a prime number. So let us check here. So 2 is a prime number. 2 is a prime number. So I will do one more thing. 4. 4 is not a prime number because 4 can be also divided by 2 and 1 and 4 as well. So there are 3 divisors. So that time we can't do that. So in here, let us add one more thing, because it have these many divisors. So for that is count. So let us check it. Let us give some random number. So it is not a prime number because it have 8 divisors. And one more thing is that other than 2, all even number is not a prime number, because 2 can be divided by 2 can divide any even numbers. So that's why other than 2, all even numbers are not a prime number. So let us give some odd number. So it says it is not a prime number because it have 32 divisors. So that's what we have to check, that you have to count the divisors. After counting the divisors, if it is exactly 2, that time it is a prime number. So let us check for 1. 1 is neither a composite nor a prime number because it can be divided by 1, because it's the same number, so there is no 2 divisors, so that's why it is not a prime number. So now let us try to print the range of prime numbers in between. For example, if I give the range of 20, or else I want to print the first 20 prime numbers. So for that we are using the same method. N is the number that we are getting. So int, instead of n, I am naming it as, so n is okay. So after that we will name it as count. For number of prime numbers we are going to print. So initially it is 0. So after that we are going to use a while loop. While my count is same as the number of input that the user want. So that time I have to check the number and I have to print it. So I don't know how many times it have to run. So for that I am using while true. So for using true, instead of that I can simply use while 1. While true, this loop have to run. In this loop it will count. So while true, we have to get to the range. So this is the loop we are going to use. So for that we are using this. Instead of that we are using count equals n. So then int, I have to use any number that can be incremented by 1. So there we have to get the range. We will not be using any for loop here. Instead of that we will be using while loop for the range, because we don't know the range. So now we will be creating a method that is useful to call it multiple times. So int I'm using int instead of boolean because if it returns 0, it is false. If it returns 1, it is true. So I'm checking is prime. So I'll get a number n. This is the input number and this is the output, that is true or false. We are going to print. So now if my number is less than or equals 1. Okay, the negative numbers to 1 is not a prime number. So return 0 is false. So after that, for int, so in the range we will be having another method, that is 1 and that is 3. For example, if I take 13, if the number is divided by these two only numbers, that time it is prime number. If it is divided by any in between number, for example 2, 3 like that, so it is not a prime number. So that's we are going to check here. Int I value is 2, because we will start from 2 and I less than or equals the same number. So after that, I plus plus. So in this range, if my number is, we don't have to use the same number, 2 to n minus 1, that is less than n. So if n is divided by any number in the range in between it, so that time it is not a prime number. It have to be divided by 1 and the same number. So I am checking by this. After that, if all of them are false, that means it is a prime number. This is for negative numbers and this is for checking in the range in between 1 and n minus 1. So within this range, if the number is divided by any of this range, so that is not a prime number, so I am returning 0. If it is not divided by this, it is a prime number, so I am returning 1. So using this while loop, we have to check that here first we have to use a number here. For that int I will be starting from 0. Starting from 2 because 1 is not a prime number. So we will be adding if is prime of 2, if 2 is a prime number, so that time we will be printing the number. So we don't need this, we just need a space. After that, the I. So here the I is the number we are going to check, and every time we have to increase it. So if it is true, I have to increase the count by 1. If it is a prime number, I will increase the prime number count as 1. So let us check it. So I want 10 prime numbers. So it is not printing anything because we didn't give, wait, let me check here. It is n, and if count is equals n, so that time it has to print something. So here if is prime number, so let me remove first this. So we will use a for loop here. First we will print the range, after that we will come here. So we will use main, int main, and return 0. We'll use n for the variable and scan it. After that, we'll use it as a for I equals 2 to I less than or equals n and I plus plus. If my number is prime number, so if is prime, if my number is prime, I have to print the number. Print a percentage d and after that I. So let us give and check the range of 20. So it is printing the range of numbers, that is within the 1 to 20 it will printing all the prime numbers. So this for loop is for the range. After that, this prime number checking is for checking how many numbers are there. So using this same method, we will be printing using the count of the prime numbers, we will be adding it. So here it will come here, and if it will check here first, 2 will be come. So after that, within the function 2 will be given as the input. So now it will check 2 is less than or equals 1. So no, then it will come here. So 2 less than 2 is false. So it will not get into this loop. So return 1 is true. So 1 will be given here. So 2 will be printed. So after that 3 will come here. So 3 will be given inside it. So 3 less than or equals 1 is false. So here it will check that 2 is less than 3. So it is true. So here 3 by 2 equals 0. It is false. So it will get out of this. And again it will check 3 less than 3. It is false. So it is come into return 1 and 1 will be given as the true. So after that it will come here. Now the 2 will be changed to 4, 3 will be changed to 4. So 4 will be here. So it will come here that 2 less than 4. So it is true. So 4 by 2 equals 0. So it is true. It will return 0. So it will become false. So it is get out of this loop. 4 will not be printed. So it will come to 5. I will come here and check 2 less than 5. It is true. So it will check by 2 modulus 5 modulus 2 is true or false. So that time it is false. Then 5 modulus 3, 5 modulus 4 will be checked. After that all of them are false. So return 1. It will return true. So 5 will be printed here. So same for that 7, 11 and 13, 17, 19 will be printed. So if I give the range of 100, or else I'll just give n here. Within the compiler I'll give 100. So 100. So within the range of 100, these are the numbers that are prime numbers. See here, other than 2, all of the numbers are odd numbers. So let us move on to the next question. That is factorial of a number. So first see what is factorial. For example, if you take 5 factorial, that is nothing but 5 multiplied by 4 multiplied by 3 multiplied by 2 and it is multiplied by 1. So this is 5 factorial. So it will be 120. So if you take 4 factorial, 4 multiplied by 3, 3 multiplied by 2, 2 multiplied by 1, it is 24. For 3 factorial, 3 multiplied by 2, 2 multiplied by 1, it is 6. For 2 factorial, it is 2 multiplied by 1. For 1 factorial, it is 1. 0 factorial, it is also 1. So other than 0 factorial, all of them will be multiplied in the range. So as you can see, it is from range of 1 to 5 and 1 to 4 1, 2, 3. That is multiplied by the range. It is nothing but product of n numbers. So let us see that. So I'll remove this code. First, include the header file. Standard input output .h. After that, main. After that, return 0. So now it is a product of n numbers. So for the product of n numbers, I am giving 1 here, because if you multiply this number initialize with 0, if you multiply, you will always get output as 0. If you use 1 here, then only you will get the value of the same number, because if you multiply any number with 1, you will get the same number. For int, it starts from 1 and ends at the same number. So the range is I is 1, I less than or equals the same number, and I plus plus. So I'll get the input from the user n, and I'm getting the input from the user. So now factorial equals factorial multiplied by I. So after that, I need to print it. So let us check here. So the value of 5 factorial is 120. So it is printing 120. And the value of 4 factorial is 24. So it is 24. Now let us check value of 6 factorial. So it is 720. So the product of n numbers is nothing but the factorial. So let us move on to next question. That is Fibonacci series. In this Fibonacci series, it starts from two numbers, that is 0 and 1. After that, the third number is sum of the previous two numbers. The 0 plus 1 will become 1. After that, the previous two numbers are 1 and 1. So 1 and 1 is 2. So 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13. And after that, 21. Like that it will goes on. It will multiply the previous two values. 1 and 1 is 2. And 2 plus 1 is 3. And 3 plus 2 is 5. 5 plus 3 is 8. And 8 plus 5 is 13. 13 plus 8 is 21. After that it is 34 and 55. Like that it will goes on. So this is the Fibonacci series. So let's try to code it. So first I want the range. I just want to print the range. If I give 5, I'll print first 5 digits. So like that I will do. So for that, int n. After that, I'll get the range. So how many terms? I'll ask how many terms. So after that, I'm using scanf. So after that, I'll print it Fibonacci series. So now, first, let us check something. That is, if my number is, there are two numbers there. That is, first number is 0, the second number is 1. So, first, my first number is 0, and the second number is 1. These two is stable. After that, the third number will be changed. So I am going to use a for loop for the range. For we have to print n terms. So I equals 0, I less than n, and I plus plus. So this is the range. In this range, I want to add both of these two and store it in some temporary variable. So I am using int temporary variable is first plus second, because the third digit is the sum of the previous two values. So after that, the first value will become this, and the second value will become the sum of the previous two values. After that, this first value will become the second value, and after that, the second value will become the sum of two values. So the first will be changed to the second value, then the second is stored changed to the sum of these two values. So after changing it, I just have to print it. I have to print the value. So now we have to print the first value, or else we have to print the added value, that is temporary value. So here I have to give %d. I have to print this. So if I run it and give 10 here, there is no space, so I'll give some space. It starts from 1, 2, 3, 5, and it skipped the previous two digits, that is 0 and 1. It skipped these two digits. So we have to print these two digits first. So for that, if my n is greater than or equals 1, so that time I will print the first digit. If my number is greater than or equals 2, that time I can print the second number. Now I printed first two numbers, so I remove two numbers from it, 0 and 1. So the loop will start from 2. So now let us check. So I want 10 terms. So it's 0, 1. So I have to give some space here, some more space here. So let us run it. So it is 10 terms. So Fibonacci series of 10 terms is 0, 1. After that, 0 plus 1 is 1, 1 plus 1 2, 2 plus 1 3, 3 plus 2 5, 5 plus 3 8, 8 plus 5 13, 13 plus 8 is 21, after that 34. So we got the range. So there are 11 terms here. So let us print 11 terms. So check it is working. So we got the same values. So let us move on to the next question. That is GCD. GCD is nothing but greatest common divisor. We are going to check for two numbers. So if I take two numbers, for example 48 and 18. In these numbers, first we have to calculate all of the divisors. For example, 1 is a divisor, 2 is a divisor. First let us see for 48. After that, 12 will be also a divisor. 6, 1, 2 and 6 will be there, 12 will be there. After that 24 will be there for 48. If you come to 18, 1 will be there and 48 is also a divisor. So now if you let come here, 2 is also divisor, 3 is also divisor, 6 is also divisor. After that 9 is also divisor, 18 is also divisor. This is for 48 and this is for 18. In this, if you see, the name is greatest common divisor. The common divisors are 1, 2 and there is no 3. So let us remove this. And 6 is there and there is no 12, 24 and 48 and 9 and 18 also not there. So the greatest divisors, the common divisors in this are 1, 2, 6 and the greatest is the largest one, that is 6. So the greatest common divisor for this 2 number is 6. So there is a easy way to find the GCD, that is while n, let us take two numbers here. So I am removing these two. I am naming it as n1 and n2. So printer, enter two numbers. After that scanner, getting two numbers from the user. So now this thing is n1 is not equals n2. If both of them becomes equal, that means the greatest common divisor, that time we can stop the loop and check if n1 is greater than n2. If n1 is greater than n2, that time n1 equals n1 minus n2. Subtract it with the lesser number. Else n2 equals n2 minus n1. So what we are doing, when the both numbers become equals, until then subtract each number with the lesser number. If it is greater, n1 is greater, subtract n1 by n2, and if n2 is greater, subtract n2 by n1. So after that just print it. Print the GCD of two numbers is, so n1. So first let us store this n1 and n2 in some variables. Int a equals n1 and b equals n2. So because we are modifying the n1 and n2, so that's why I am storing it in another variables. So a, b and any value. Let me give n1 here. So let us check 48 and 18. So the GCD of 48 and 18 is 6. So we got the value. So 48 and 18 is 6. So let us check for some more values. That is 45 and 45. So it should return the same value because it is the greatest common divisor. So let us check for 45 and 90. 45 and 90. This also should return the 45 because it is divided by the both numbers and it is the greatest value. So let us move on to next problem, that is LCM. So there is a formula there, that is, if you multiply these two numbers, after that if you divide these two numbers with the GCD of two numbers, that time you will get the LCM of these two numbers. If you multiply n1 and n2 and divide by the LCM of n1 and n2, that time you will get the GCD of, if you divide by GCD you will get LCM. If you divide it by LCM, that time you will get GCD as the output. So this is the formula we are going to use here. We have now found the LCM of the numbers, sorry, GCD of the numbers, we have to found the LCM. So for founding the LCM, so I am taking one variable, multiply the two values. We have stored it in two temporary variables a and b, and we have to divide with the GCD value, that is n1. We have currently found that. So now we'll just print it. The LCM of these two numbers is this LCM value. So I am giving two values. So let us check for same numbers, 48 and 18. So the LCM is 144. LCM stands for least common multiplier. So let us check for 12 and 16 or 12 and 18 here. So now we should get the GCD is 6 and LCM is 36. So 12 and 18. So let us give here the next line and run it and give 12 and 18. The LCM should be 36 and GCD should be 6. The GCD is 6 and the LCM is 36. So now it is working perfectly. So let us move on to the next problem, that is perfect number. So what is a perfect number? As you can see, we have already seen about the divisors. If a number, for example, let us say take 6, if a number divided by another number, for example 1, and if it gives 0 as the remainder, it is a divisor. So that time what we have to do, if a number having the sum of the divisor other than the same number, and if it gives the same number as the output, that is a perfect number. These are the divisors of 6, and if you add all of them and if you get the same number, so that time you will get the output that is called as a perfect number. Okay, let us try to write for the code. So let us remove this. So in this we will get int n. So I am getting input from the user. Before that I will print enter a number. So now after getting the input, we have to calculate the divisors. So we have to add the divisors. So for adding, I am initializing with 0. If you are multiplying, you have to initialize with 1. So I am giving the range of I equals 1 to I less than n, because we don't need to add the same number, because the same number is also a divisor. So we are searching from the range of 1 to 6. For 6, see here the range is, this is the range we have to check. These are the divisors of 6. This will not divide 6. So, if my number is divided by I and gives return as a 0, it is a divisor. So, if it is divide, I have to add it to the sum, total sum of the divisors. So, now if my total sum is equal to the value of my same number, so I can print it is a perfect number. Instead of it, I'll just give percentage %d. After that, then or else it's not a perfect number. We are adding the divisors of the number. If the number, the total sum of this divisor is same to this number, so that time it is a perfect number. So let us check for 6. So 6 is a perfect number. So let us take another numbers. We take 28. It should be perfect number. If we take any other numbers like 2, it is not a perfect number. And 1. After that, if you give any prime numbers, it is not a perfect number, because prime number only have two divisors, the same number and 1. For every prime number, you will get the output of the sum of number is 1. So all the prime numbers are not perfect number. So let us see some more problems. So let us move on to another problem, that is strong number. So first we will see what is a strong number. Let us take some sum, that is, if a number is 145 and the digits of its factorial, the sum of digits of its factorial is equal to the same number, that is called as the strong number. It is 1 plus 24 plus 120. It is 145. So the sum of digits of its factorial number is equals to the same number, that is called as the strong number. So we already know how to separate these digits and how to get the factorial of a number. So let us see that. After getting the number, first I'll store it in another number variable, because we are going to remove the digits, so that time it will become 0 finally. So for that, while, so this time I am using temporary is not equal to 0. That time I have to remove the last digit. After removing the last digit, I'll just, before dividing, we'll use for loop to find the factorial of value. So for the factorial, we are going to multiply it. So we have to store it in some variable. So I am using int res equals 1. We know the factorial, that is we have to multiply it 1 to the same number. So int I equals 1 and I less than or equals the same number, that is remainder, after that I plus plus. In here, result star equals I. We are calculating factorial here. After that, we have, after calculating, we have to add it to the total value. So the total sum is 0. So sum plus equals the factor of the single digit. After that, we have to remove the single digit in the last. So temporary equals temporary divided by 10. We are getting the last digit. After that, we are finding the factorial for it and adding to the total sum and removing the last digit. So now we are calculated the total sum. If my n is equals the total sum, so that time I can print this number is a strong number, or else it is not a strong number. Now let us run it. We are extracting the last digit. After that, we are finding the factorial for each digits and adding it to the total sum and dividing by 10 to remove the last digit. So let us check for 145 because it is a strong number. So 145 is a strong number. So let us check for another numbers. For example, if I give 0, no, 5, so 5 is not a strong number. So let us check for 4 because 4 factorial will be 144. 4 factorial will be 24. In here 5 factorial is 120. After that 4 factorial is 24. So 144. After that 1 factorial is 1. So 145 we got the value. So let us move on to the next question. That is sum of the series. For example, there are a lot of problems there. In the sum of series we can add it by 1 by 2 like that. So in the sum of series we are going to do one problem. That is nothing but the sum of the harmonic series. So let us see the sum of the harmonic series. So the sum of the harmonic series is nothing but 1, after that 1 by 2 and 1 by 3 and 1 by 4 and 1 by 5. Like that it goes until 1 by n. So this is the problem. In this we are giving the range. After that we will be adding these numbers and printing the sum of the series. So this is called the harmonic series. So we will write the program for that. First see the requirements. The n is the range and we had to add using divided by values. So in that case we will be using float here because there can be float values. Float sum equals I am giving 0.0. After that we will be printing. Before that we have already printed, so now it's no need for that. So now we have to use a for loop for the range. For I equals 0 or 1 and I less than or equals n, because we are going to 1 to the range. So 1 and it will goes to the range and it is increased by 1 every time. So for that I plus plus. After this range we are going to do sum equals what we are doing. It is nothing but not just 1 by 1. So 1 by 1 is nothing but 1. So that's why it is simply 1. So now we have to divide the value n. It's 1. So 1.0 divided by I. After that we are adding it. So just print it. the sum of series that 1 plus 1 by 2 plus 1 by 3 and so on 1 by n is we'll be printing the output here, so percentage d and sum. So let us try to print it. So let me give the range of 10 here. So it goes on to some minus values. So let us give 3 here. So it says 16106 some value, because it is dividing 1 by 2, 1 by 3 like that. So it will goes on. So what we are doing, we are getting input. After that we are putting float here. So here it is percentage here. So now we'll give 10. So this is 0.100 some value. So we are doing iterating from 1 and 1 to n and incrementing by 1, and here it is sum plus equals. So now let us give the range of 10. So this is the value 2.98928,968. So we have already seen about the power of the value. So let us see one more time here. For that we will be getting two inputs, that is the number. After that I am naming it as k. So I want to scan n here, after that k is here. Before that we have to scan before scanning the other value, and we are printing enter the exponent value. This value is for the power, the k is for the power value, and this n is for the number. So we are going to run the loop k times to find the power of this number. So I am using int power equals. So we are going to multiply. So for multiplication use 1 and addition use 0. So for I equals 0 and I less than, then I is incremented by 1. So now we have to multiply it. So power equals power multiplied by n. So these many times this value will be multiplied with the same value n. So after that we will print the value of the number power the another number is the total power value, that is n, and k is the power value. So let us give the number is 2 and I want the power of 3. The value of 2 power 3 is 8. So let us check here again. So my number is 5 and the exponent value is 23. No, 3 is enough, 125. So 5 power 3 is 125. So this is the problem for the power of the value. So let us see one more problem, that is we are gonna convert that binary to decimal conversion. For example, a binary value of 10 is 10 and 10. So here we have to calculate this. This is 2 power 0. What we have to do is first 0, this last digit multiplied by 2 power 0, plus this 1 is multiplied by this digit is multiplied by 2 power 1. After that 0 multiplied by 2 power 2. After that 1 is multiplied by 2 power 3. So this 0 is multiplied by 2 power 0 will become 0, and 1 is multiplied by 2 power 1 will become 2 power 1 is 2. So 1 multiplied by 2 will become 2. So 0 is multiplying this value, so it will become 0 here. So 1 multiplied by 2 power 3. 2 power 3 is 8. 1 multiplied by 8 is also 8. So 8 plus 2 will become 10. So this conversion I have manually done is going to done by the compiler. So for that we are going to write the code. So for that I want to use include math function here. So I want to include math function here. So now, so let us remove this. First, I am going to get a long digit because it can be in a long way, that is multiple digits will be there. So for that I am getting from the user. So before that I will print enter the binary value. So I am getting the binary value from the user. So after that we are going to do the same thing. That is, first we have to remove this digit and multiply it with the 2 power 0. So for that this is starting from 0. The power value is starting from 0, 1, 2, 3 like that. So for the power value, I am going to declare that a variable that is I. So the I starts from 0. So we are going to remove the last digit anyway. So while binary is not equal to 0. So int remainder equals the last digit. We are getting the last digit, that is I am named as remainder. So now I want to convert it to decimal. So for that I am storing it as integer. Int decimal is 0. So to store it in somewhere, so I am using as decimal as 0. So now we have to multiply this current digit. After that, see here the formula is the current digit is multiplied by 2 power I. So it is 0, 1, 2, 3 like that. So for that decimal equals the current decimal plus the current decimal plus the last digit, that is remainder. Okay, the last digit is multiplied by power of 2 and I. So for that there is a inbuilt method there. So we can simply use power of 2 and I. So instead of calculating this, we can use POW, that is power. For that we have to include this math function. After that we can calculate it. So now we have to remove the last digit. Binary equals binary divided by 10. So after every iteration, I have to increase the power of I plus 1. So now we have to print it. Printer, the decimal equivalent value of the decimal equivalent value is that is percentage. Before that we can give percentage here. After that the value that is binary here, and the final value decimal. So that this value is become 0, so we have to use a temporary variable long on temporary value is binary. So I'll name it to temporary. So let us check. The value of 1010 is 10. So it is working. So 0101 is 5. So let us check for that. 0101. So it is working. The value of 0101 is 5. But here it is showing that it is not, it is the leading 0 is not visible, but it still works. There is no need for the leading zeros. So we have seen about this binary to decimal to binary conversion here. So let us move on to the next problem here. So let us see the automorphic number. So check a automorphic number. A automorphic number is a number whose square is ends with the number itself. For example, if we take 5 and the value of pi square is 25. See here the last digit is the same digit as the number. So that time it is a automorphic number. If we take 6, the square of 6 is 36, it ends with 6. And if I take 25, the square value is 625. So that time this last two digits end with 25. So next number is 76 and the square value is 5776. So the last two digits is ends with the same number. So this is what we are going to check, that is automorphic number. So we will write a program for that. So here first I'll declare some values int n. After that we have to find the square value. So square, and we need some temporary value to store it and digits. So now I'll print enter a number and I am scanning it. So for the square, I can multiply the number with itself. So I got the square value. If you don't want here, we can remove all of this and we can simply use here itself the square. After finding the square value, I am using a temporary variable to store the current number. So after that, while temporary value is not equal 0. So I want to count the number of digits. So for that, I'll declare int digit count is 0. So count will be incremented and every digit is divided by 1. So it is digit count. So now we have counted the number of digits here. After that we have removing the digit and we got the square value here. So now we will check the values. That is, first what we have to do, we have to check for these divisors. There is 6 and 36 and 5 and 25 and 25 and 625. These are the numbers. So now here if you can see here, we have to get the last digits of square. Okay, for that we have to multiply it with 10 from the range of 0. So for that we will be doing one thing, that is I am using a variable divisor. So I am naming it div is 1. So I want to multiply it. So now I'll use a for loop range of for I 0 and I'll get to the digit count. So in this range I'll multiply it by 10. So I'll counting the digits of it 10. So after that I have to get the last digits. So for that I'm using last digits. Within this we have to get the square value, okay, square value divided by the divisor. So as you can see here, if you divide a number with 10, modulus, if you divide a number with 10, you have to use modulus here. If you modulus by 10, you will get 1 digit. So if you modulus by 2, you will get 2 digits. Same here, we are counting the digits of the number. So let's see here, this is 1 digit. So we have to check last 1 digit. If it is 2 digit like 25, so that time we have to check for the 2 digits. So for 2 digits, you have to multiply by 10 2 times, then you will get 100. So 625 modulus 100 is nothing but 600. So 625 minus 600, you will get 25 as the output. So now we got the last digit. See here, this is the last digit we got from the user, that is 25. So this is also 25. So for that only we are counting this divisor count. So after that we are checking the last digit. So I am storing the last digit in here. So here my value n is equals the last digit. So that time I can say it is a automorph number. If it is not, it is not a automorph number. So see here, this is for count. This is used to count the number of digits we want to check. So after that we are multiplying the divisor by 10. So we will get the digits as it. If it is 1 digit, you will get 2 divided by 10. If it is 2 digit, you will get 2 divided by 100. So this 25 is 2 digit. So dividing by 100, you will get the remainder as 25. So you have to check that 25 is equals the current number. So now let us run it to check the examples. If I give 5, this is automorph number. 6 is the automorph number. 25 is the automorph number. After that 76 is the automorph number. So now let us check for the other numbers. For example, let us take 10. 10 is not an automorph number. So let us get 9. 9 is also not an automorph number. So there are few numbers that will be exist among this. So let us move on to the next problem, that is neon number. So what is a neon number? A neon number is number that where the sum of digits is equal to the square of the number itself. For example, let me remove it. Let us take 9. So the value of 9 square is 81. If you add these digits, you will get the same number. 8 plus 1 is 9. So it is equal to the same number. So first the number have to be squared. After that you have to add all the digits. If it is same equal to the same number, so that time it is a neon number. So let us write the program for it. So first we got input from the user. Now we have to calculate the square value. The square value is the number is multiplied by itself. Now we got the square value. So now I want to store it in a temporary variable so that we can add it using the digits. So int. So I want to use some value to calculate it. So I'm using sum equals 0. So we have to add the digits. So while the temporary variable is not equals 0. So that time sum equals sum plus we have to add the last digit. For adding last digit, the number divided by 10. You will add the last digit. Now you have to remove the last digit. So we will get the sum of its value. So we have, this is the square value. We have adding this temporary value will get the square of this number. Now what we are doing, we are adding the digits. So now we have to check if the sum is equal to the value of the current number n. So that time we can print it is a neon number. We can remove this it and add the number. So I want to add one more printing statement here, that is the value of it. So for here percentage d power 2 is the square value. Okay, the current number square is this value and sum of digits is equals to the number, that is percentage d. So here I can give n, after that the square value, after that the total sum. If it is not, then we can print percentage d is not a neon number. So let us check. So 9 is a neon number, so let us check for it. So 9 is a neon number. So after that I'll give a next line here. So 9 is an even number and 9 squared is 81. The sum of its digits is 9. So we got the value. So this is how we will be checking it. So let us move on to the next question, that is called as pi number. A pi number is one where the sum of its digits is equal to the product of its digit. So for example, let us take one number, that is 1 1 and 2 4. If you add all these digits, you will get 1 plus 1 2, 2 plus 2 4, 4 plus 4 8. So the product is 1 times of 1 is 1, 1 times of 2 is 2, 2 times of 4 is 8. So the sum of its digits and the product of its digits is same, then it is called as a pi number. So let us write the program for it. So we get the number. So we have to calculate two things. First, I'll store it in another variable because we have to do one thing. That is, we'll be dividing by checking the last digits. So for that, we are getting two values. We are adding it. So sum equals 0 and we are multiplying it. That is product. So product equals 1. So while my temporary value is not equal to 0. So that time sum equals sum plus temporary value divided by 10, modulus 10. So now I'll get the remainder and adding it. But for the product I have to multiply it. So product equals product multiplied by temporary divided by 10. So temporary modulus 10, it will give the output of the remainder value to add it. So after adding and multiplying those values, we just have to remove the last value, that is temporary equals temporary divided by 10. After doing those things, we just have to check the both values. So here my sum is equals the product value. So I can print it is a percentage D is a pi number. After that the number value, that is n. So if not, I have to print it is not a pi number. So what we are doing here, we are extracting the digits and adding it and multiplying it. If both of them are equal, it is called as a pi number. So let us give the value of 1124. So it should return 8. So the value is a pi number. So if it is not pi number, for example, if I give 1, 2, 3, so both values 3, 3 plus 3 plus 3 6. So it is also a pi number. So if you use, it is not a pi number because the product is 24 and the sum is 10. So that's why it is not a pi number. So let us see one more problem, that is abundant number. So a abundant number is a number that the sum of the proper divisor is greater than the number. For example, Let us take 12. So here the devices are 1, 2, 2 and 3 and 4 and 6. In the proper devices, this number will not come. Before that, all the devices will come. In this, if you add all of this, you will get 16. If the sum of all the proper devices is greater than the number, that is called as a abundant number. So let us check it. So I am getting the input from the user. After that, we have to check for the devices. So I am we have to add it. So anyway, I am declaring a variable, that is sum. So for it will be starting from 1 and it is less than the current number and increased by 1. So in this range, if my current number is divided by, if my number is divided by the range of the number and returns 0 as the remainder, so it is a divisor, so I have to add it to this variable. So I am adding this digits. So now if my sum is greater than my current number, so that time print this number is abundant number. If it is not greater than this, so it is not a abundant number. So let us check it. So there is one more thing is there. In this number, if it is greater than this, it is an abundant number. So after that, if the sum is equals to the same number, it is not abundant number, but it is called as perfect number. We have already seen perfect number here. That is, if the sum of its proper divisors is equal to the same number, that is perfect number. If not, it is called as deficient number. It is called deficient number because it is less than the value. So let us check for some numbers. 12. So 12 is a abundant number, but it's printing 1 here because we didn't assign the value of n. So n and n. So n here as well. So let us check it. So 12 is a abundant number. So again 4 is a deficient number, and 6. So 6 is a perfect number. So let us check for 8. So 8 is also a deficient number. So let us move on to next question. That is Disarium number. So Disarium number is nothing but the sum of digits of powered by their position is equal to the number. The power to the number is nothing but, for example, let us take 135. So 1 power 1 plus 3 power 2 plus 5 power 3. So if you take it, 5 power 3 is 125 plus 3 power 2 is 9. So 134. After that plus 1 is 135. So this is a disarray number. First digit will be given as the power of 1. Second digit will be given the power of 2. Third digits will be given the power of 3. So let us try to code it. So again we have to sum it anyway. So in sum will be 0. So after that we will be using digits again. So that time you have to use temporary variable to store the current value. So first we have to count the digit. So here we can do one more thing, that is counting the digits. After that we can do that thing. So for that, in first we have to count it. So I'm creating one more function for that. So in I'm naming it as count, or else count digit. Within that we have to give a number. I will count it. So I'm declaring one variable to count it. After that, while my number is not equal 0, count plus plus, and one digit will be removed. N divide equals 10. So after that I'll return the count. So using this method I'll get the count of it. So I'm using temporary variable to store it. So now I'll declare one variable, that is digits. So I just call this method those. So after that it will count the value and store it within this variable. So now while temporary variable is not equal 0. So now I'll use in digit. So in this I'll extract single digit. So after that sum, I'm adding it. So what I'm doing, the power of, there are positions there, that is, see here we have to add it with along with 1, 2, 3 like that. So in this the digits has to be, first the count is 3. So it is there are 3 digits here. So first I'll power up this with 3 and reduce it to 2 and again 1. So like that I can do. So the power of the current digit with the digits, that is nothing but the count. Currently it is 3. So now we have to reduce the value of digits to 2. So digits minus minus. So now the count will be reduced to the 2 to get the power of this value. So I will reduce this value to next, or else you can do one more thing, that is you cut this out and paste it here, and you don't need this because every time in the loop it will count for the every digits and store it. So but we don't need that because it will call the function multiple times. So we'll just do this only. So we are reducing it. After that, here sum equals my n. The total sum is equal to my current n value. So I can print it is a Desarium number. If it is not, it is not a Desarium number. So first I want this number to be printed, so I am changing this value to n. So again changing this value to n. So let us check. So let us give some examples. So 135 is a Desarium number. So we let us check for the another number, that is 175. So let us check for another number, that is 518. 518 also a Desarium number. So then let us check for some other number like 54. So it is not a Desarium number. So let us see one more problem, that is called as a duck number. A duck number is contained 0, but it doesn't start with 0. For example, if I take any number like 105 is a duck number and 2017 is a duck number. After that 3050 is a duck number. But 01 is not a duck number and 05 is not a duck number and 0 is not a duck number. Any number starts with 0 is not a duck number. So we have to check by using a Boolean value. So let us remove this. So I am getting an input from the user, that is n. So it can be long because there will be multiple digits here. So I am changing it to long and this is long digits. So now I have get from the user. So I am storing it in a variable. So let us name it as original. So after this, I can say here my number is equals 0, or I will convert this into long. The power of 10 and the I am converting this int value to log 10 of the original. So this will count the digit by less than 1 and we are adding to the power value and it is power of 0. So if both are equal to 0, so it is not a duck number. So it's a special case. We don't need this, but we just need this one. If you don't understand, just leave that. So we can just print out it is not a duck number. So there itself I can stop this program. So we will check if a number contains 0 within it. So while number not equal 0, that is n not equal 0, So here, if my n modulus 10, that is the remainder value, if equals 0, so it has 0. So I will create one boolean value. For that I am using integer. I am naming it as has 0. Initializing with 0, 0 means false. So now if it has 0, I am changing it to 1. 1 means true. So after that I will break it. There is no need to check anymore. There also it is a duck number. So now number divided by 10, that is n. n equals n divided by 10. So we are dividing every last digit and check if any digit is 0. If has 0, if it contains any 0, it is a duck number. So now let us check here. If it have 0, will print is a duck number. After that, so after printing it, if it is not a duck number. So let us check some numbers. 0 is not a duck number, and 0 1 0 2 2 5 or 3. So it is not a duck number. If any number that contains 0 in between the number, that is a duck number. So for example, if I take 10, 10 is a duck number because it has 0 and it is not starting with 0. But 0 is not a duck number. A number that should have some number within it, after that alongside it have to have the number. So let us give 2017. It is a duck number. So we have solved around 25 plus problems. So in this we have seen basic operations like even or odd, sum of digits, and after that special numbers, Armstrong numbers, and GCD, LCM, all of the concepts along with it. So that's all for this today's video. So we'll be covering more of the topics after that. So make sure to follow along with it so you won't get missed any in between sessions. If you follow right along with the live sessions, you'll get to see more problems and